Hey everybody, it's Brian here with another SPSS video. Today we're going to do a one-way independent groups ANOVA. So an ANOVA is an analysis where we are comparing means, but in this case we have a single independent variable that has three or more levels, three or more groups that we're going to be looking at. And a one-way ANOVA allows us to compare those three or more means simultaneously to see if there's any differences among any of the means. And if we do find a significant difference somewhere among those means, we can do post-hoc tests to further understand exactly which groups are different from which other groups. So we're going to do that in SPSS. I have our movies SPSS file open here. And our independent variable for this example is going to be the age group. We have 1, 2, and 3. So we have 3 levels of this age group variable. And then our dependent variable is going to be the movies watched. How many movies have you watched in the last 3 months? So it'd be nice to have a little bit more information about what these 1, 2s, and 3s represent. There's a couple ways to get at that. We can go to the variable view. And then here in the values, if we click here, then we click on this little 3-dot button. We see that 1 is for kids, 2 is for teens, and 3 is for grown-ups. So another way we could see this on our data view is if you go to the view menu and check this value labels box. Now any of those variable values that are set are pulled into this data view as well. So that can be really informative, that we can see that person number 1 here is a kid, and he watched 10 movies in the last 3 months. Person number 2 is also a kid, watched 24 movies, and so on like that. So having the values pulled over is just a convenience when we're looking at our data view. But let's do our one-way ANOVA to see if these different age groups have a different number of movies watched. To do that, we go to Analyze, and we choose Compare Means, and we choose this last one here, a one-way ANOVA. So the independent variable is what SPSS calls our factor. So we're going to pull that down here into the factor. And then the dependent list is going to be our dependent variable, the number of movies watched. There's a couple things I like to check, at least one for every one-way ANOVA that I run. Under options here, I like to check the descriptives, and that gives us the means for each group and some other useful information. So let's go ahead and check that and run our analysis. So we check the descriptives, so it gives us this first box, which shows us for each of our 3 groups how many people were in it. We have our n's. And then most importantly, the means that we're comparing, these 3 means. It also gives us the total number of participants across all 3 groups and the grand mean, the total or the average of all of our participants combined. But moving down to the ANOVA results, here we see this looks very similar to the hand calculations we did in class. We have our sums of squares, the degrees of freedom, and this is a great way to make sure that we set up our data, our variables correctly. This degrees of freedom, we're comparing 3 groups, so this first one should be 3 minus 1 or 2, so it looks like that's correct. Sometimes if you switch the IV and the DV when you're setting that up, it's a very easy thing to mix up, but then this degrees of freedom, this first degree of freedom is going to be noticeably off because you'll have many, many more groups than you were expecting to have. So that's a good thing to check as soon as you check out this analysis. Here's our mean squares, our F obtained, 4.56, and then finally our p-value, the sig column here. So we see that a p-value of 0.013 is a nice significant result if we have an alpha of 0.05. So we can say, yes, somewhere among these 3 means, there are significant differences. So the appropriate response there is to do some post-hoc tests. So we can redo this analysis and turn on the post-hoc test option. So we go back to compare means, one-way ANOVA. Thankfully, it's remembered everything we've set up, so we don't need to redo that. And now we can click on this post-hoc button. And let's do our good friend Tukey. We'll check the Tukey box and leave everything else the same. And we're going to redo this entire analysis, so we'll get the same information we got out. But now we'll get the post-hoc information as well. So here's the redone analysis with our descriptives, our ANOVA result, and now we can see this multiple comparisons table is telling us which groups are significantly different from which other. So there's some duplicated information in here, so it can be a little bit hard to read. So let me walk you through this. So we're comparing group I to group J. So for the first row here, group I is the kids, and we're comparing it to the teens. So here's the mean difference for that I minus j. And then here's the significance. Are those two groups significantly different? And with a p-value of 0.998, we would say no, kids are not significantly different from teens. However, if we compare on this next row down, kids to grown-ups, there's a mean difference of 3.8 movies and a p-value that is less than 0.05. So we would say kids are significantly different from grown-ups. Moving down to the next, it has teens to kids. And notice this is the exact same comparison that we saw up here. We're just switching the direction of the comparison. So instead of a positive mean difference, we have a negative mean difference. But the significance doesn't change at all. It's still a non-significant difference. This is new. Teens compared to grown-ups, we have their mean difference, as well as a p-value here, 0.03. So we see that teens are significantly different from grown-ups. And then these last two is duplicate information from what we've already seen. First, we compare grown-ups to kids. See that's significant at the 0.025 level, which is the same as we saw in this first or in the second row here. And then similarly, grown-ups to teens, significant at the 0.03 level. And that is a duplicate bit of information. So it's sort of giving us every possible pairwise comparison and in every possible order. So that's why we have 6 total p-values here, and knowing that there's some duplicate information in there. So now that we know sort of the baseline, grown-ups are different from kids and teens, but kids and teens are not different from each other, I find the best way to sort of finally process this is to go back to the descriptives. And now we can see, oh yeah, here are the kids and teens, their mean is about 19.5, 19.42, and these are not significantly different from each other, but it's the grown-ups with this 15.7. So now it's a lot easier to sort of eyeball the direction that the grown-ups are watching significantly fewer movies than the kids and teens are not watching significantly different movies compared to each other. So that is a one-way ANOVA with the post-hoc test. And so there we are in SPSS. So thanks for watching, and I'll catch you guys in a future video.